Okay, so 4.6, if this will focus. Okay, we're operations and augmented matrices. So the first thing that we are going to do is write an augmented matrix. So basically this is what you do when you have a systems of equations. This is just another way to solve it. When you are making an augmented matrix, you follow this format. So you take, so it's x1, y1, x2, y2, then like a separating line, constant 1, constant 2. Okay, so what does that mean? Okay, so if we have this system right here, okay, if this will focus. Camera's being a biatch. Okay, well, okay, it's working. Okay, so x1 would be, you always look for the coefficients, by the way. So this would be x1, and this would be 7, because 7 is the coefficient to x. This would be y1, right there to 3y, and then the coefficient would be 3. And, why is this? Okay, x2 would be 2, because 2x, 2 is the coefficient. Then 3y, it would be negative 3, because look at that minus sign there, so negative 3y. So y2 would be negative 3. So the way you would write this out would be, so remember x1 was 7, x2 was 2, y1 was 3, and then y2 was negative 3. Alright, and then look at the constants, 4 and, 4 and 10. So you would just copy that down pretty much directly. So you just do, so this is what it would look like. And then write for 4, 10, matrix. Okay, so now, once we have the augmented matrix, and if you don't understand this, probably gonna have to just text me, I'll respond. Okay, so, what to do from here? Well, remember when I said, this is the x, this is the y. The goal is to make this, is to make the, so say this is row 1 and row 2. Okay, if I can write properly. Row 2. Okay. The goal is to make, so say we make this x 0. We want this to be 0. Then this has to be 0 too. The whole point is to take out one variable for each, for each equation. And I know that probably makes no sense, but I'll explain it. I'll work this one out. Okay, so let's just say that we're going to start off by making the bottom 0. This is how you do it, and it's a little tricky, but you'll catch it. Okay, so new matrix. Okay, so now, okay, they conveniently gave us this 3 and negative 3. You can add it and it'll be 0. So you're always trying to get that 0. And notice this is the y. Y, x. So, if we were to add these, this is the way you do it. So, you would, the way that you're doing this, you would keep the top. The key is whenever you add or subtract, one of the equations will stay and then the other one will get replaced. We would keep the top. So you would do this 7, 3, 4. Wait, why is my handwriting so bad today? 7, 3, 4. And then the bottom one would change. So let's add these. 9, 0. Very important, 0. And then 14. Okay. Okay. Something looks wrong here. No, this is right, Okay. So, now that this one is 0, the Y slot 0, we have to make the X slot 0. And the way that you do this is, Richmond was talking about how you have to try to get the identity matrix. That sounds complicated. The way that you have to do it is if you can make whichever one you want 0 first. I chose to make this 0. So the way that the way you know where to go next is just look at the diagonal. This one right here also has to be 0. This 7 has to become a 0. If this was a 0 at first, then this would have to become 0. If I made this 0 first, this becomes a 0. You just look for the diagonal. Do not worry about this at all. This means nothing right now. So now the 7 has to become 0. So how do we make this 0? Well, in this one, we conveniently were given this, but now you're going to have to multiply this row by something to get this. So this is what you do. Look for it's the same thing with the system kind of, where you're multiplying the LCM, the least common multiple. So we can multiply this by 7, and this by 9, and then we're going to get a finally good matrix. 7 times 9 is 63, 27, 36. Okay, notice 7 times 9, that's also 63, but then 7 times 0 is 0, so the 0 will still stay, so don't worry about that. 7 times 14 is 98. Okay. Then we subtract, and you already know that this has to be 0, so you can go ahead and subtract, make this 0. And the key is you have to know which one is 0 and which one's staying. Here, whenever you're doing this, the top one always stays. I'm pretty sure that's a safe statement for me to make. Top one always stays. The bottom one changes. Then when you're doing the second one, then the top one will change, because it has to. It has to for this to work, and you'll see. Okay, so 63 minus 63 is 0. 0 minus 27 is negative 27. 98 minus 36 is 52. 62. My bad. And then then we still keep everything from right here, so this will be 68. 0. 98. Okay. Oh. Okay, so this is our matrix. So, you know that this is the y, this is the x. You divide the matrix by whichever one you have. So right now we don't have an x, so we divide it by the y, which is 27. So off to the side, divided by 27, divided by... Now this one would be, you have the x, not the y, you divide by the x, 68.